Okay, so here's the exam question that we saw. Right, so someone firing a shot at a target from 25 to 90 degrees. Probability we're given is P equals 3 over 200 times 90 minus D. Each shot is fired independently, that's important. The cadet fires 10 shots from a distance of 40 meters. Okay, so our N is 10 and our D is 40. So we've got to find probably exactly 6 shots hit the target. So that means that basically for this example, P is equal to 3 over 200 times 90 minus 40, and therefore it equals 3/4. So X is roughly distributed with the binomial distribution. N is 10, probability is 0.5. So for the probability that it's 6, so the probability that our discrete random variable hits is equal to 6 is 0.145998. Okay, and that's simply using the PD function. For the second one, the probability that at least 8 shots hit, so X is 8 or larger. Okay, again, cumulative distribution, it starts from 0, so I've got to make that 1 minus P. X is less than or equal to 7. Okay, and that gives me 1 minus 474, and that means my answer is 0.5256. Okay, so that's that. Right, B. Now the cadet fires 20 shots from a distance that we don't know. So now we know that N is 20, but D we don't know. Now normally I can work my way back from the probability I'm given, but as I don't know P, I can't do that. So that means that basically X is roughly distributed with a binomial with P of 20, but we don't know, sorry, with N of 20, but we don't know what P is. Okay, so, but we do know, it says he hits the target at least once. So the chance of hitting the target is at least 1, and we know that the answer to that is 0.8.
Has he replied?
So again, we reverse that, 1 minus P, that X is less than or equal to 0, is 0.8. Well, that just leaves us with a probability that X is equal to 0, so he doesn't hit anything. And the probability of that has got to be 0.2. And we know that the probability of missing is 1 minus the probability of hitting. So that means he misses 20 times, and that gives us 0.2. So we take the 20th root of 0.2, and 1 minus P is equal to 0.922688, which means the probability is equal to 0.0773. So there's a 7% chance of him hitting at least once with 20 shots from there. But that's not the answer to the question. That's the probability. So we know the probability is equal to 3 over 200 times 90 minus X. And now we know what that probability is. That's 0.773. So we rearrange this. 90 minus X is equal to 773 over 150. And X is equal to roughly 84.84 meters. Okay, remember basically, because we're talking about distance, be really careful if you use the units. Right, now for C, the cadet fires 100 shots from 25 meters. So we know that N is 100, our distance is 25 meters. So our probability is 3 over 200 times 90 minus 25. And that equals 0.975. Great. Okay. Problem is, if I do NP, that gives me 97.5. Okay, well, and I've got quite a high probability. So what I'm going to do is I'm going to use the binomial. So I've got Y. Well, let's say X is our probability of hitting it. So X is binomially distributed, and that would be with 100, with a probability of 0.975, and that's for hits. Or y is 100 with a probability of 0.25, and that is misses. So if I want the probability of this being y being greater or equal to 95, which is what the question asks for, that's the same as P of x being less than or equal to 5. Because if I have 95 misses, I've got to have 5 hits. And that way I can work out what my probability is. Hope this helps.